welcome to another video of IBMAA breakdown. Today we'll be covering 1.3 under number and algebra, which is also under the both SL and HL content. So the topic I want to answer is geometric sequences and series. Today, this will be a lot shorter than the previous one, as I intend to make all of them shorter. Okay, so geometric sequence and series was an example. So, for example, 1, 2, 4, 8, 16. Unlike arithmetic sequence, which have a common difference, geometric sequences have a common difference, which we also call R. In this case, it's times 2, right? This case, times 2. And similar to the arithmetic sequence, there's also the other factor of the initial term. For example, I can have start with 2, and then even though I have exactly the same common ratio, it's still a completely different sequence, right? Okay, so carry forward. The sequence also looks kind of funky when you have a negative common ratio. So something will look like this. Is also a geometric sequence as they are timing -2 to each term. Okay? Good. So I hope that gives you an overview of how overall geometric sequence looks like. Now we're gonna get into the more IBMAA style type of stuff. So you mentioned that there are two characteristics, which are your common ratio and your first term, U1. This is the same as arithmetic. Okay, so how do we generalize this? So let's look at the case we had. So we had 1, 2, 4, 8, probably one of the most simple one, and they're timing 2, right? So if I write this as U1, U2, U3, U4, U5, I'm timing R here. So U2 actually equals to U1 times 2R. Right? U3 equals to U1 times R, which is U1R squared. Okay. And U4 equals to U1R cubed. I hope you're following the trend here. So that's fairly straightforward. Now, what you should notice is that this number is this number -1. Right? Always. And in the case of U1, you're actually timing to U1 times R to the 1 minus 1, 0. R to the power 0 is 1. So U1 equals to U1, that still works. So that leads to your first formula under 1.3, number 1. In a geometric sequence, UN equals to U1 times to R n minus 1. Okay? This is the fourth formula. This is fairly straightforward, very similar to the arithmetic one. I recommend you to watch that too if you haven't, if you're unfamiliar with this, because geometric sequence and arithmetic sequence are essentially the same thing. They're very similar. Okay, so we mentioned that the second thing we should talk about is how do we express this in a sigma notation. This is actually, I'll argue this is even easier than arithmetic sequence, because you can just have for intro to sigma, you can also watch the previous video on arithmetic. Let's see, very generally, sigma goes to infinity from 1, right? And then this is also in your formula booklet, I believe, and then it will just be U1 times 2R n minus 1, because this represents each term. Okay, so I'll give you an example. Okay, so let's say we have, again, 2, 1, 2, 4, 8, 16. So this will be U1 and infinity. My common ratio is 2. My initial term is 1, so I just write 1 times 2 to the n minus 1. Right, and then my first term will be 1. My second term will be 1 times 2 to the 1, so that's 2. Third term is 1 times to 2.2. That's 4. Right, so that matches. Okay. These are all notation-wise. I'm going through them relatively quickly. And I have also decided that these videos will just be explanations. Practice questions will be included in another video. if they are needed. Okay, so here we are going to the next step, method to calculate sum. So I hope you are noticing I'm following a similar structure between arithmetic and geometric sequence, and I hope that will help this to reinforce a more structural memory. So I'm starting with notation to sigma, and then to how to calculate sum. I hope you follow this structure clearly, which should help you to reinforce the memory. Okay, so the good thing is, in 1.3, I'm only gonna cover the finite terms of geometric sequence. If you're looking for 1.8 on the infinite sum formulas, that'll be covered in another video when we get there, because that's a little bit more tricky than this one. Okay. So finite, you have the formula in 1.2 number 2, right? So the sum is u1 equals times 2 rn minus 1 and r minus 1 sum equals, and that also equals to this. So I hope you realize that this is actually exactly the same thing, right? So why is that? Because you're really timing -1 on both top and bottom, right? If I time both on the top, that becomes u1 equals to -rn minus 1 and r minus 1, which equals to 1 minus rn and 1 minus r, right? So that works. That's exactly the same formula. Exactly. If you don't get how this works, you should try to expand this, a minus b and -b minus a, right? If you expand this, that will go into that. I recommend you to try that by yourself if you don't get it. It's actually a very handy trick sometimes. Okay, so we're gonna try to prove this. Oh, sorry, you probably can't see that. We're gonna try to prove this, right? So let's go down. Okay. So let's follow the same idea. So if you look at the original for each terms we have u1 equals to u1, u2 equals to u1r, u3 equals to u1r squared, right? This is all coming from the formula that we saw earlier. Right. Okay, so let's just talk about this then, right? So this whiteboard's getting a bit small now. Okay, so if we add them together, right, I'm gonna go to u1 r n minus 1, right? That'll be my final term. We can factor out u1, so u1 times to 1 minus 1 plus r squared dot till rn minus 1, right? Right, make sure you're following until this step. If not, you can pause the video and think about it. I simply factored out u1 as u1 is in every term. Okay, now we're gonna cheat a little bit. Okay, so we know the formula is u1. Okay, hope you should be able to see that. Okay, so my formula is u1 times 2 rn minus 1 over r minus 1, right? So I got the u1, right? That means if I prove these things are equal, right, then my proof is done. Okay. It's always okay to cheat a little bit. Actually, I'm not actually cheating. In mathematics, we always, if you can't go from A to B directly, it's okay to go from B back and then meet somewhere in the middle, right? That's perfectly reasonable, right? So now I want to know if, sorry about that, that's the wrong term. Plus r squared dot rn minus 1. I want to know if that equals to rn minus 1 and r minus 1. Right. And let's pretend that's true for a second. If this is true, I'm going backward. If this is true, that means this must be true. I time r minus 1 on both sides. Right. Now, if I prove that this second line, which I'm circling right now, if I prove that this second line is true, then I'm proving the first line is true because they are an equivalent statement. They're equivalent statement. Equivalent statement. Okay. So, and this is much easier to prove than this because doing this division is a huge pain. But doing this expansion is actually a lot easier. So let's see. So if I have r minus 1 times to the 1 plus r squared till r minus 1, right? I simply distribute, right? If I do r first, that means r's power will increase by 1 at each term because I'm timing it to an r. So I have r plus r squared till r times n, right? This is what I get for r. And that will minus timing 1, which is the original one. Right, okay. And then notice how r squared, and this is minus, right? So these all cancel out until the last term rn, because this one doesn't have rn, and 1, because this doesn't have 1, the previous term. So I have r squared minus 1, right? And very nicely, that goes to here, right? Which is the original statement we had. So therefore, I have proven that Rn minus 1 divided by Rn minus 1 equals to 1 plus R till R minus 1. And hence, the sum equals to U1 times to Rn minus 1 over R minus 1. So this is the sum formula. Okay. So here I have given a very brief introduction to the sum formula. In the future, hopefully I'll make some practice video with IB style questions for practice on how to use them. But I intend to make every video a little bit shorter so that it's much easier to navigate. And yeah, so this will be it. And if you have any homework questions or questions you see in your mocks that you want me to go through, feel free to send them in the email, andrewmaths2021@gmail.com. It's linked below. And you can find more IB Maths breakdown video also in the link I followed below. Right. I'll appreciate if you can like and subscribe. That really means a lot. Feels weird to be a YouTuber. But yeah, well, thank you, and I wish you best luck in your IB journey. Thank you.